Hello, I'm Ryan McEachran, and welcome to The Dig. On this episode, I will be talking with Sam Bott from Titan Environmental. When we think about ground support in underground mines, we think about rock bolts, metal screening, and sometimes shotcrete. But regarding metal screening, what if there's a product that is lighter, easier to handle, lasts longer, and is cheaper? Well, there is. So let's dig in now with Sam Bott from Titan Environmental. Hi, Sam. Welcome to The Dig.
Oh, it's great. It's a great opportunity to be here. How are you doing, Ryan?
I'm doing very fine. Thank you very much. And I'm glad to have you on the show because,
My pleasure.
when I hear about geosynthetics, I think of liners to tailings ponds and road stabilization. But when you started talking about it in terms of using it for ground support underground, I was very intrigued. So can you tell us a little more about that?
Certainly, Ryan. Very well said. Geosynthetics are really exciting and emerging materials, high technology engineering materials for the last 30 years are used for stabilization and reinforcement on different applications. Now, for the last 10 years or so, the trend is changing that to get away from the metallic meshes, which have all the problems of corrosion and they're injurious, they're difficult to handle, slow process. So these grids, which were already there, they were more tweaked to be more, suitable for the underground mines. So that means the grids already had the properties of high strength, high modulus, and things like that. So we added, at the Titan, we did a lot of advancements in it, over the years. We added anti-static feature, fire resistance or fire retardance feature into it. We changed the upper sizes of these grids so that it can handle any kind of dowels that are used in these underground mines. So
Right.
keeping that in mind, we created these grids which could easily replace the conventional steel meshes. You could go from weeks to days to complete one job, and high productivity, less injurious, and efficient.
Oh, excellent. And that's a good point because I guess when people consider, well, if I was to put this in ground support, it would now I have a risk of something catching fire, but you've dealt with that issue.
Yes, in fact, you'll be pleased to know, Ryan, that we did testing of these grids in Australia for the safety, from the safety perspective, because Australia is very strong in mining. And in fact, the Mine Safety Technology Center, which is from the government of Australia, they did the anti-static testing. That means what is the capacity of it to get inflammable or to ignite. So there are 112 attempts in that test. It did not ignite. So it gives us a lot of confidence on our products. And we did, and this one particular, for example, is from polyester. They have an fire resistant and anti-static coating both. These have special additives, UV additives and fire retardant additives. So we have tested them all to extremes to ensure that they are safe for tunneling and underground, for example, hard rock or soft rock mining without any issues.
Right, right. And as we mentioned when we introduced the show, it's this is obviously lighter than a metal or steel screening, and it sounds like it's a lot easier to handle. Why is that?
Well, I think that's simply logical. I mean, suppose I'm keeping this small animal in my hand, it's very light, but it has strength, I would say, 3 times more than the steel. And not only that, when you use the steel meshes, they have round ribs, and sometimes from the roof, the rocks do fall through them, and that's a safety hazard. You cannot stop that. But here, you've got a bigger surface area. You can see here, the ribs have a bigger surface area, right? So those rocks are stopped there. And when we start placing them, I mean, you can imagine, compared to the steel meshes, you can carry more of those, place them on the roof or the rib, for example, put them together, put the dowels, and you're done. In the long shield recovery screens, Ryan, that experiment has been done that if you compare the fastness with the conventional meshes, you are talking of going from the weeks to the days. Now, if that much time is saved, how much money is saved? How much increase in productivity is there? So I don't think, miners in Canada, I know it's a little more conservative here, they should certainly consider these new technologies. With foolproof stabbing, we can provide them whenever they need it.
Right, and that's my question I was going to ask was, it's something that I haven't heard or seen too much about in Canada, but You mentioned you were testing in Australia. Have they picked up on it?
Oh, yes, certainly. Ryan, I'm pleased to tell you that we have been using these mining grids in Australian mines for the past 5 years now.
5 years.
So, yes, and recently we have started talking. In fact, it was again, it was from the mining show that we had in March, the last show, pre-COVID this year, as you know. And there were some mining companies from Mexico who visited our booth, and they were very interested. They said, "Hey, what is this?" We said, "Yes, it's a mining grid." "Oh, can it replace the steel?" I said, "By all means." And we are talking to those mines now, and they are very interested, Ryan. And in fact, those mines, they have some of their mines are joined with Canadian mining companies, which is very interesting. So at the moment, they are finding some budget to start some trials using these meshes. That will be very interesting, actually.
Right, very interesting. And you've also you've customized the product to handle, say, the sides or the shoulders of an opening, and also specialized for the back.
Definitely, right. What we have tried to do is, because see, we know the grid technology. We got to make it as easy and simple to the end user in the mine, so that they find it easier to work with. That's why we want them to switch and good for environment. So we can customize the lengths and the widths of these grids to suit a particular shoulder and the roof or rim, for that matter. We can also tweak with the apertures as well. We can go from 1 inch, that's 25 mm, up to 100 mm without compromising on the engineering and tensile properties of the grid. So that's awesome. So we have a lot of flexibility to cater to different mines.
Right, right. And it is a new product to me, so I'll ask what may seem a silly question, but this can act. It sounds like it's a higher quality replacement to the traditional product, but you can shotcrete over this as well. I'm just asking the question. Is it?
Oh, definitely. No, it's a very good question. That's no, every question is very precious, right? Yes, you can do that by all means. See, end of the day, look at the surface of this material, all composition of this material. They are made from, polymer materials like polypropylene, or it could be the high strength and high tenacity in polyester, and made into the grid form, either by punched and drawn or by heating or the weaving process, like here. And then strong coating on the top of these grids. By all means, you can shotcrete on top of them, and they're chemically and biologically inert. So they don't react with acids or alkalis, and they can operate in a pH. We have tested that also based on the durability of these materials. They can operate in a pH big range, like 2 to 13 for that matter. So that covers a big gamut of the pH range. So that's why we can use them also in, tailings, in heap leach pads and all, where there's some very acidic environments.
Right.
This could work very well. It should not be a problem.
Right, right, and I'm glad you brought that up, because I was thinking, a real benefit too is in a highly acidic, at least acidic, or it sounds like highly basic as well.
Or alkaline as well. Both.
This thing is very stable in that regard. So yes, another plus to it as well. And I imagine being long lasting. I don't know, I'm not aware of it, but you could effectively reuse this material if you were to kind of go into another area.
Yeah, once you cut it, it's in good condition, it can be reused. And then looking at the long lasting or the durability of these materials. In fact, these, since a lot of tests have been done in terms, like it has a tensile strength that is short term that we do now. Then we project what is the long-term strength by taking the various factors that it can lose over time, degradation factors we call. And keeping that in mind, we calculate the long-term design strength, which is also very high based on what numbers we use. So the long-term design life that we are talking here is around 120 years. And no matter what you do to steel, no matter what, you do any kind of galvanizing, coating, what happens after 30 to 40 years. We have seen in the research, experiments with universities, the bonding gets away. It's just 20% of the bonding. That is a fact. Now here, what happens because of, these are the meshes, they stay. Even if when we reinforce this, due to interlocking, the bonding is very strong. But in the mining environment, they easily handle the load, distribute the load, and we can go up to 1,000 kilonewton per meter by 1,000 kilonewton per meter in two directions. That's way higher than steel, but yet much, much lighter than steel. So then I think, it should be, one should gladly can think of using it and saving the time and money and save the environment.
Exactly. Well, and there is a trend, a long-term trend, that we're just going to go deeper with our operations. And so it's been a real pleasure having you on the show here explaining this. I can see how this would be, definitely a benefit to any underground mine. And great to see that it's had traction in Australia. It's getting interest in Mexico. I look forward to seeing it in Canada. So thank you very much, Sam.
Thank you very much, Ryan. It was a great pleasure to be here, and have a great day. Thanks a lot.
You too. Take care. And thank you for joining us on The Dig. Until next time, I'm Ryan McEachran. Take care and stay safe.